Okay, so we are given a function of f of x being equals to 3x to the power of 3, and 9.1 we are asked to find or solve for f of x is equals to f of prime of x. So f of x is given as 3x cubed, and f of prime of x is going to be 9x squared. So if you equate the two, equals to f of prime of x, and then if 3x cubed is equals to 9x squared. You transpose this to the other side, you have 3x cubed minus 9x squared equals to 0. Factorize 3x squared into x minus 3 equals to 0. So it's 3x squared equals to 0, therefore x is equals to 0, the first solution of x, or x is equals to 3, so this is the second solution of x, right? So we are done with solving this problem here. And then 9.2, we are given graphs of f prime, f prime prime. All passes through the point of origin of 0 and 0. So 9.2, for which of the graphs will have 0, 0 as their stationary point? The first derivative, f prime, so let me write it properly. So f prime will have a stationary point, and graph of f will have a stationary point. So 9.2, explain the difference, if any, in the stationary points referred to. So f prime will give you your turning points. So it give you your turning points of the function. So let me write turning points, right? And then our graph of f will give you, I can give you your x-intercepts when the function of f is having the turning point at that intercept, right? So, or it can give you the point of inflection. So what do I mean by it will give you the x-intercept? You can have a situation where your cubic looks something like this, and then it looks like this, right? So this point here is the turning point of f, right? Of function f of x. It's a turning point. It's also an x-intercept, and this region here is 0 and 0, so it's stationary, right? So hence I'm including this statement of saying it will give you the x-intercept if at that region it is a turning point, right? And then you have your point of inflection there. So done with this section here. And 9.3, determine the vertical distance between the graph of f and f prime at x equals to 1. So f prime is equals to 9x squared, and f prime prime is equals to 18x, right? So the distance is equals to the difference of these. So it's difference of f prime prime minus f prime, right? So it's 18x minus 9x squared, of which x is equals to 1. So the distance is equals to 18 into 1 minus 9 into 1 squared. So it's equals to 18 minus 9, which is equals to 9. So that is the distance, d. And then 9.4, for which values of x is f of x minus f of prime of x is less than 0. So f of x minus f of prime of x less than 0. What is our f of x? It's 3x cubed minus our f prime of x is equals to 9x squared less than 0. So you're going to factorize 3x squared into x minus 3 less than 0. So your critical values are x being equals to 0 or x being equals to 3. So you're going to write down your timeline and indicate your critical values of 3 and of 0. So these are going to be your critical values, right? And then you're going to test values before the critical value, which before 0 there comes -1, between 0 and 3 there comes 2. So I'm just going to circle the values that you're going to test, and then comes 4 here. So if you substitute, looking at this equation here, if you substitute x equals to -1, this value here, you should get a solution that is negative. So I'm just going to write negative. And then if you substitute x being equals to 2, right, which is this one here, so you should get a solution that is -2, right? And then when you substitute x equals to 4, which is this one here, you should get a positive solution, right, of y. So we are mostly interested in negative solutions because of this inequality sign saying it's less than 0, right? It's not greater, it's less than 0. So your solutions of x can be as follows. You can say x is less than 3, right? I'm talking about these 3. So I'm using the critical value to interpret that when x is less than 3, we're having a negative solution of y, which is exactly what we're looking for. Or you can say x is, I think x less than 3 just highlights even this portion here, right? So I can leave it there, or someone can just say when x lies between 0 and 3 and x is less than 0, right? This also applies, especially if you write them both. They both apply. So yeah, we're done with this question here. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.